The high school robotics team designed a robot to toss t-shirts for sporting events. At the current power setting, they calculated that the path the t-shirt tossed from the robot can be modeled by the equation y equals negative 0.02663 times the quantity x minus 26 squared plus 18, where x represents the horizontal distance in feet and y represents the corresponding height in feet. If there's no picture shown, you should really try to draw a picture. So here's flat ground, robot shoots a t-shirt, and then it lands, following a parabolic arc. This particular equation is written in vertex form, so we should be able to pick out the vertex for this parabola. The vertex is 2618. Now let's think about what that means. That means that 26 feet in horizontally, the t-shirt will be 18 feet high in the air. So our first question, how far can the robot toss the shirt? Say the robot tosses the shirt, nobody catches it, it just follows the path and falls to the ground. How far will that shirt have gone? So if from the starting point to the vertex is 26 feet, we know that a parabola is symmetrical, so from the vertex to the other side would be another 26 feet. What is 26 plus 26? 52. So how far can the robot toss the shirt? 52 feet. Now, do you feel like we had to do a lot of really complex math to get that answer? No, we just had to pick out what the vertex is and then think about what does that vertex mean. All right, B, what is the maximum height of the tossed t-shirt? 18 feet. We talked earlier about maximum and minimum. So the y value of the vertex is the maximum or minimum value. 26 feet horizontally into the t-shirt's path, that t-shirt is 18 feet high. If a fan is 23 feet from the robot on flat ground, would it be possible to catch the t-shirt? So 23 feet would be like right about here. So if it was your average person standing here, could they catch that t-shirt? That without running toward or away from the t-shirt, just standing there on flat ground, which means no jumping, can they catch the t-shirt? No. Not unless they're almost 18 feet tall with their arms stretched out. So, why or why not? The t-shirt is almost 18 feet high at that point. So, I mean, if like Shaq was standing there with his arms up and jumped, I still don't think Shaq can get up to 18 feet jumping. Well, it doesn't say there's a trampoline, so we're going to assume there's not a trampoline. The path of a shot put released at an angle of 35 degrees can be modeled by the equation y equals negative 0.01x squared plus 0.7x plus 6. All right, I am going to be completely brutally honest with you. The 35 degrees was put there by an evil math person to make you doubt yourself and to make you think that it's more complex than it is and to make you think that you can't do it. We don't need that 35 degrees. It doesn't matter at all. So do not let that 35 degrees give way to your doubt. We don't need the 35 degrees. We don't care. We only care that the path of that shot put follows the parabola that uses the equation y equals negative 0.01x squared plus 0.7x plus 6. That is standard form, so I know that our a value is negative 0.01. Our B value is 0.7, and our C value is 6. What is the maximum height of the shot put? Okay, now I'm going to be honest with you again. If it's in standard form, there is a little bit of math that we have to do. We have to find the vertex. But we've been practicing finding the vertex in standard form, so that shouldn't be that big of a deal. So we need to find the vertex. And your steps for finding the vertex are first to find the axis of symmetry and then plug that number in. The axis of symmetry is the opposite of B over 2A. So negative 0.7 divided by 2 times negative 0.01. If you punch that into your calculator correctly, you should get 35. If you want to punch it all in one step, I would suggest you put parentheses around the denominator. It's really better to multiply the denominator and then do the numerator divided by the denominator. You should get 35. So this vertex is 35 comma something. It was pointed out to me that this 35 is the same as the angle. That is completely a coincidence. It is not always going to be that way. So again, completely ignore the 35 degrees because that doesn't really matter for this problem at all. And it's completely a coincidence that we ended up with 35 as the vertex. So 35 is the first part of our vertex. That means horizontally 35 feet away from this thrower, the shot put is some height. That's what we have to figure out. So we need to plug that 35 into our function. And I'm going to write this with parentheses around each of the 35s. And I'm going to put this in my calculator exactly as it's written. I don't even use the multiplication button, I just use the parentheses, and the calculator does that work for me. So that means the vertex is 35, 18.25, which means that the maximum height of that shot put is 18.25 feet high. So 35 feet into the path of this shot put, the shot put is going to be 18.25 feet high. Approximately, how far from the shot put thrower does the shot put land? Approximately 70. Now, why are we saying approximately? Okay, so from the shot put thrower to where the vertex is, that's about 35 feet. We say about because there's this piece of the parabola missing. The shot put leaves from her hand. We're missing that chunk of the parabola, so we're missing that distance horizontally on the ground. So it's about 35, but it's not exactly 35. And then from the vertex to where the shot put lands would be another 35. So approximately is used because we're missing part of that. And that point right there is the point 0.6, which means that shot put is 6 feet up from the ground when it leaves her hand, so we're missing that chunk of the parabola. All right, I made a big assumption in this problem. I used feet as my label. It will usually be written for you. It should have said up here in the problem where x represents the horizontal distance in feet and y represents the corresponding vertical distance, or the corresponding height, in feet. So a properly worded problem would have explained with more words, blah, 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 in feet, blah, 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 in feet. Okay, turn the page and let's look at the third word problem. Yes, I'm completely not creative, so here's another robotics problem. The robotics team modified some settings on the t-shirt throwing robot, and now the path of the t-shirt can be modeled by y equals negative 0.3 times the quantity x minus 4 times the quantity x minus 22, where x represents the horizontal distance in feet and y represents the corresponding height in feet. If there isn't a picture, you should draw one. So, choo. This particular equation is written in vertex form. So this did I say vertex form? Totally meant intercept form. This is written in intercept form. So the x-intercept here is the point 4, 0. The x-intercept is at 4. The other x-intercept is at 22. So the x-intercepts are at 4 and 22. How far can this robot toss a shirt? So it looks like the robot starts 4 feet out from something and tosses the shirt, and it lands 22 feet from that thing. So between 4 feet and 22 feet, how many feet is that? 18 feet. And how do you get that? 22 minus 4. 22 minus 4 is 18 feet. So this length right here is 18 feet. What is the maximum height of a tossed t-shirt? We can pretty easily figure out the first part of this vertex. We need to find the point that's halfway between 4 and 22. So 9 feet away from 4 and 9 feet away from 22, or add 22 and 4 together to get 26. 26 divided by 2 is 13. So 13 feet is the horizontal location of this vertex. To find the corresponding height, we need to plug 13 in. Because the vertex is symmetrical exactly between these two intercepts, when you plug in the x value of the vertex, in those parentheses you should end up with a matching pair of numbers, one of them positive, one of them negative. That indicates that this vertex is 9 units away from each of those intercepts horizontally. Multiply this out, what do we get? 24.3 feet. So this vertex is 24.3. 13 feet into this toss horizontally, that t-shirt is going to be 24.3 feet high. So to wrap all of this up, if you know how to find the vertex in all 3 forms, you basically have all of the information you're going to need.